Hey everyone, today we're going to talk about the percentiles under the normal curve. In our previous video, we've talked about the areas under the normal curve and how we can use the table of areas under the normal curve, which is this table here. For today's discussion, we're going to talk about the percentiles under the normal curve, and these percentiles can be expressed using the areas under the normal curve. But when we talk about percentiles, these are expressions of relative standing. It is a descriptive measure of the relationship of the measurement to the rest of the data. So here's how it works. For example, we're given here with a normal curve. This is our normal curve, and let's say that this is the middle. Remember that in our areas under the normal curve, the area to the left of this middle is 0.5, and the area to the right is also 0.5. When we talk about percentile, this line here represents 50% of the population to the left and 50% of the population to the right. So the areas actually represent their populations. So for example, if we say that we have this line here, let's say this is the line, and we've determined that the area to the right of this line is 0.4. This area here, this score here, this is the 40th percentile of the data, since the scores before this score compose of 40% of the population, while if we have, let's say, this score here, another score, and we've determined that the area from here up to here is, let's say, 0.9. This means that this shaded area here represents 90% of the population, and this score X here is the 90th percentile, since the scores before that score represents 90% of the population. So this is the 90th percentile. So let's have an example. So first off, let's determine the percentile of z is equal to 1.62. So this is our z-score. Remember, in terms of z, this middle part here is 0. Then we have the first, second, and third standard deviation. Z is equal to 1, 2, 3. And let's have it here, 1, 2, and 3. Take note that these lines are just arbitrary lines. We just have to label where the first, second, and third standard deviations are. So this is not the actual position. It's just an arbitrary point. So let's determine what is the percentile of z is equal to 1.62. So what's 1.62 is 1.62 standard deviations above the mean. So it's 1 and 62. So somewhere here, let's say that this point here is z is equal to 1.62. So we would like to know what is the area of the scores before it. So this is actually the area that we're talking about, this area here. So let us use the normal table. So the table of areas under the normal curve. But remember, in our table here, it only represents this part here. So I'm gonna shade it with a different color. Let's say red. The table under the area under the normal curve only accounts for this part here shaded in red. But what we'd like to get is the one shaded in blue. So after we've received the area for red, we have to add 0.5 to this part, so that we would know the area before the z equals 1.62. So let's use the normal table. So that's 1.6, then 0.02. 1.62 is somewhere here. This one, it's 0.4474. So this means that this this red one here is 0.4474, and the blue before that is 0.5. So we have to add 0.5 and 0.4474. Therefore, that is, let's adjust it here. It should be, the error is 0.9474. We just added 0.5 and 0.4474. The sum is 0.9474, which converts to 94.74%. So this means when we round off 94.74, this is approximately 95%. So what does this mean? This means that the score z is equal to 1.62. This is the 95th, or almost at least, the 95th percentile, because the scores before that z is equal to 1.62 represents the 95th percentile. Okay, let's have another example here. Let's say that in a given set of score, the mean is 20 and the standard deviation is 5. What score is the 70th percentile? So that's what we'd like to know. So this is 20 here and the standard deviation is 5. So let's say that the standard deviation are right here. 1, 2, 3. 1, 2, 3. Remember, these points here are just arbitrary points, huh? So we would like to know the 70th score. Remember that in determining the z-score, we have z is equal to the mean, the score minus the mean divided by the standard deviation. But this time, what we'd like to know is the score itself. So we are going to transpose this so that we would know the value of x. So multiply both sides by standard deviation. This would be z, standard deviation times z is equal to score minus the mean, which becomes standard deviation times z plus the mean is equal to x. So first, what we'd like to know is what is the score that corresponds to the 70th percentile. So we have to know the z-score first, then multiply it to the standard deviation, then add it to the mean to get the score. So in order for us to know the z-score, we will use the table of errors under the normal curve. So this is 78 percentile, so let's pretend that it's right somewhere here. We're not actually saying that it's literally here, huh? I'm not saying that the score is in between 1 and 2. We're not really sure, but it's a good estimate though. So we're looking at the score which divides this normal curve such that the area here is 0.7. That's the 7th percentile. So we are going to look at these scores here in the middle here. So let's see. Let's look at, since this is 0.7, this is 0.7, remember that this half here is 0.5, so we are actually looking for 0.2. What z-score corresponds to, or at least closely corresponds to 0.2? So that is this one here, 0.1985. And there's another one, 0.2019. But considering we're looking at 0.2, 0.1985 is much closer. So we are going to get this one, and this is 0.52. Therefore, the z-score that corresponds to this one is z is equal to, where is it? 1.985, 0.52. 0.52. So it should have been somewhere here. Yan. 0.52. So we are going to use our formula in order for us to determine the value of x that corresponds to z is equal to 0.52. So let's use this formula here. Remember that the standard deviation is 5 and the mean is 20. So let's go here. So let's have this one. The standard deviation is 5. Was it 5? Yeah, it is 5. So let's have 5. The z-score is 0.52 plus the mean, which is 20. That is equal to x. Let me double check my given here. The z is 0.52, yes, and the mean is 20. So let us perform the operation here. So let's bring out our calculator here. So this is 5 times 0.5, sorry, 5 times 0.52. That's equal to 2.6 plus 20 is equal to 22.6. Therefore, x is equal to 22.6. Therefore, this score 22.6 corresponds to the 70th percentile of the scores. So the scores before x equals 22.6 is the 70th percentile. So that's how we go around in determining the percentile of the scores in a given set of data. So we can use this to determine how well does a particular score stand with the rest of the group in terms of percentile, not just in terms of percentages. So I hope you guys learned a lot today. In our next video, we're going to talk about word problems on normal curve. And thank you guys for watching, and see you guys on the next video.